Assalamualaikum and good day everyone. So my name is Muhammad Daniel Putra bin Shahrul Nizam, metric number CE200225. So I'm from group 7. So today I want to explain about assembly language code in LMC. So the first thing we must to do is uh, we generate the code. Okay. So this is my group equation which is my group choose a minus b plus c power of 2 times d divided by e. Okay, the first thing I do is I declare the input, which is I declare the a b c d e, which is this is a b c d e. Okay, so this value I store in here. Okay, 95 until 99, and then I do the minus and plus, which is in here. I load 95 is A, minus B 96, and add 97, which is the C. So I store at 85. Okay, I store at 85 and 86. So I want to see the value is I put out. So this part is to do some power of 2, which is answered at 85 and 86. I multiply it, so we come power of 2. So first I load at 96, I branch n, and then I sub 1, I store at 86, I load ans is in here, ans is 0, 1 is that one. Okay, so I store back, I branch loop. Okay, so I look at ans out, I store. So the answer that I multiply two value at 85 and 86, which is I store at 87. So we can see the answer at 87. Okay, so I sub ans, I store ans, which is I want to I sub ans because I want to declare a 0 back. So I can use this ans and 1 at the loop at number 2. Okay, loop loop 1. Okay, this is the loop 0. Loop 1 is we declare as I want to divide, which is d divided by e. So load 98 is d. Okay, 99 is e. So this is the code for the divide one, which is load. Okay, I put n1 because if we put n, so it will jump in here. So we must change n1. I load 98, sub 99, store at 98, load ans, add 1, store ans. So branch loop. So to 1, and then I end back. So I load ans and then out. So the answer will be C. The answer will be C. Okay, so I store the answer, the answer that d divided by e in 88. Okay, in here. Okay, we know the answer in here is divide. So I sub ans, I store ans. This is because I want to use back. Okay, the loop number 2 is to do uh the code, which is the answer in here. Okay, multiply the answer in here. Okay, so this is the code. So I look back the answer, I store at 88. Okay, and then I branch and I sub 1, store at 88. I load ans back. I add with uh, 87. I store ans, and then I branch loop at here. So if n, I load ans, I out. So we can see the answer at 89. So I sub ans and store ans. We can use ans and 1 in the next code. So HLT is we stop the code. If we put HLT in here, okay, if we put in here, so the code will read here until here only. So it cannot read here. It can't read here. Okay. So that is the explanation a little bit about code. Okay, so I just show a little bit. Okay, this is the code that I made. So I just submit, and then so I click run. So I just put 10. So it will be stored at 95. So I enter, okay, in here. If we put 2, it is stored at 96. Okay. So the next explanation I will pass to my member. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adif Syahmi bin Zamali CE 200102. So right now I will continue our group presentation, which is how do the data or address is obtained or assigned. So I will show you how the arithmetic works on our LMC, which is 10 minus 4 plus 6. So based on here, I will continue my previous friend presentation where he already put the value inside the address. So based on our coding, we will store or put we will put 5 times input and it store at address 95 until 99. Before that, we know this as a MAR or memory address register, where it store the register, and this is MDR, memory data register, where it store the data or instruction. So let's go. First, it will take the value inside the address 95 to put inside the accumulator, which is 10. So accumulator value change to 10. Program counter will keep at one value. Then we will take value inside address 96, which is 4. So 10 minus 4 is equal to 6, and it will store for a while inside the accumulator. So next you will perform plus 6. So right here we can see it will take the value inside address 97. So the answer is 12. 4, 10 minus 4 plus 6. So next you will see the value at the output is 6 right here. Before that, it will store inside the address 85. So we make it fast. So yeah, you can see here the output is 12. So for the power of 2, we need, if I show you inside the LMC, it will take a lot of time. So we know that the LMC cannot works on power, multiplication and division. So for power, we need to add a lot of times the number inside of bracket here, which is 12. So we need to do 12 plus 12 12 times. So we will get the answer is 144, and 6 over 3 we will do subtraction, and 4 times right here we will do addition. So for an example, 12 power of 2 is 144. So times 6 over 3 is 2. So 144 times 2, we need to do the 144 plus 144. So we will get the answer inside the LMC. So I will jump straight into our output to show our equation is true. So right here, before this, I've shown you on how we get the 12 value. So here we can see 144 because 12 power of 2, where we add 12 plus 12 12 times, and 2 we got because of 6 over 3, and 288 we got from 144 times 2, where we do the addition right here, 144 plus 144. I think that's all from me. So for the next part, I will pass to my group members, which is Muhammad Faiz Amiruddin. Thank you.
Assalamualaikum, my name is Muhammad Faiz Amiruddin bin Abdullah. My matrix number is CE20005, and I am going to explain the last part of our presentation, which consists of four functions of the CPU. The first one is program counter, instruction register, address register, and also accumulator. So for first thing first, we need to know the definition of each function, which is program counter. Is to store the address in memory of the next instruction to do. For instruction register, it is to hold the top digit of the instruction that read from memory, while for address register, it is to hold the bottom two digits of the instruction read from memory. And the last one, the function of accumulator, is to store the result of the last operation or calculations. Right, so to see how the program counter work, we need to click on the run button first. So if we click on the run button, automatically the program counter will go to the arithmetic unit, and the arithmetic unit will go back to our program counter and count it as 1, and of course it will display it as 1 instructions. Program counter count the instruction into 1, so it will be instruction and address register turn to obtain their address from the memory box. Right, so how do we understand the instruction register and address register work? So basically, we need to remember back what we have learned before, which is instruction register are going to hold only the top digit of the memory address, while address register will hold the bottom two of the value of the memory locations. Right, so if we click run button, automatically the instruction register and address register will go to the memory box location and take the value of the like this memory box location of 0, and take and then the instruction register will obtain the memory memory value of 9, and address register will be 01. So as I said before, the instruction register will hold only 1, which is top digit of the memory locations, and address register will hold bottom two digit of the memory locations. Right, so for the last part, we are going to see how accumulator work. So remember that accumulator will store the result of the last operation or last calculations. So in this case, the accumulator will store the last calculation or the last operations. Alright, so for the last part, which is accumulator, we are going to see how accumulator are going to what we call it, store the last operation or last calculations. So first thing first, I need to insert the value of desired equation into input box. So for example, I will insert the value of 10 into the input box. So what happen if I click on the run button, or I just push the enter button, automatically the value of 10 which is in input box will go to the accumulator, because the accumulator will store the last result, the result of the last calculation or the last operations. So automatically the accumulator of 10 will be stored in the memory box of 95. Right, so what if I put another value into the into the input box first? Let's say I put 4. Right, so automatically the accumulator will store the value of 4 into its function, and then automatically the accumulator will be store the value of 4 into the memory address location of 96. Right, so that's all from me. Thank you.